Good morning, ladies and gentlemen. So today we have one interesting question which reads to say the waiting time X at a bus station is measured in minutes, is uniformly distributed over 0 and 5. What is the probability that someone at the bus station would wait longer than 3.8 minutes for the bus? So when we are dealing with such kind of questions, we need to understand one thing. Remember, probability is a huge entity and broken down in small pieces for us learners to understand. So, remember, this person has to wait for more than 3.8 minutes, which means they can even wait for 3.9, they can even wait for 4.5, they can even wait for 20.1. But we are restricted, and if we are restricted, which means we are looking at what are referred to as parameters. So, if we are dealing with what are referred to as parameters, we are dealing with the two kinds of probability which would come into play. And which probability are those ones? We have what is referred to as discrete probability and continuous probability. So when we talk about discrete probability specifically is assigned to an individual. So if discrete probability is assigned to an individual, then we need to understand that continuous probability is the value which is continuously measured but is governed with a parameter, and this parameter we are talking about is 0 and 5. Both of them, they are continuous. Both of them are accounting probabilities. Even this one you can count 3.8, 3.9, but the difference is that this is governed by a parameter which is from 0 to 5. So no matter how much this person will wait, greater than 3.8, they should only end on 5 minutes. So this kind of question we are dealing with is what is referred to as a continuous probability. And the continuous probability density function is defined by this expression here, 1 over b minus a 0, where we have the values of x to be greater than or equal to a but less than or equal to b, where else it is 0. So what we mean when we say where elsewhere it is 0, if we assign time to an exact individual, the probability is always 0. I will deal with this in the next video. I bet someone is lost here. So let us now focus on this major question exactly. So what basically is being done here is, remember the probabilities are 0 and 5. I will draw the probability density graph so that we can have a little more knowledge of what I'm trying to put across here. So when we are dealing with the probability density graph, this is how it looks. We have just a simple shape here. You can call it a square, you can call it a rectangle due to the differences in time, the ones you have been given. So you have this one to be called the A, and this one here to be called B, and this one here is what is referred to as 1 over b minus a. This is what is referred to as the height in the other sense. So remember, so for us to be able to fill up this data that we have our b. Remember, we have been given this as our parameter 0 and 5. So you say 1 over 5 minus 0. Remember, these are just letters which we have put. You can put any arbitrary letters, but specifically they love these in math. So 5 minus 0 is still what? Is still 5. So this is the probability density function, the one which is governing us for us to solve this particular question. So here we have a 0 and we have a 5 here. Yes, we know for sure that 0 is there. Let us just shift our graph so that someone doesn't ask a lot of questions. So we know for sure that our A will be here because this is where our 0 is. So let us just remove it here to avoid unnecessary questions. So this is the area we'll try to find. Remember, when we are governed by two parameters, they are always taking us to what is referred to as the integral. So we go back to calculus a bit. So we are governed by the integral, where we have the b and the a here. And we should always note to say that the value of the integral we get is always positive, even if it is running from negative infinite to positive infinite. When it is running from negative infinite to positive infinite, the value is always 1. Never forget that. So when we are now dealing with this particular question, remember the number which we should put here is this number, the one we are from getting, which is 1 over 5 dx. So now that we have done that, remember they want the probability that this person waits more than 3.8 minutes. So this a now no longer becomes a 0, it becomes a 3.8. Why? Because it is starting from 3.8. When we are dealing with this, we always say greater than or equal to, which means it will start from 3.8. So which means this a has gained 3.8 and this b is 3.5. Remember, in integrals, we always say the area is starting from 0, ending from the specific number that we found of x. But in this case, the number that we were given is 3.8. So now, having done what we have done, we will integrate 1 over 5. When we integrate 1 over 5, we get the value to be 1 over 5x. Those who haven't watched my videos on integration, I will attach a video in the description of this video so that we gain momentum, so that we are together. Then now that we have done that, so what else now to do is we'll just replace. So 1 over 5, we have a 5 here, minus 1 over 5 again, and a 3.8 here. And we know for sure that this is 1. Then we can just say 1 over 5 multiplied by 3.8, and we get the value to be 0.76. Sorry, 0.76. And if we were to subtract 1 minus 0.76, we get the value to be 0.24. So this is the probability that this person will basically wait more than 3.8 minutes. Yeah, we just took so long to explain this video, but there are more concepts attached that I wanted to explain so that we are together and we should not only memorize for our studies. Your host, Golden Zulu.